we've done confidence intervals with proportions, we've done inference testing with one sample. Now we're going to move on and do inference testing with two samples. And the question that we are going to ask is, are these groups from the same population? Here is what we're going to talk about as we go through this section. So we're going to test the claim that when college students are weighed at the beginning and the end of their freshman year, the differences show a mean weight gain of 15 pounds. So is this the freshman 15? Now this has to do with means. We're going to focus on proportions. We will talk about how to do means in the next subunit. This would be one that we could talk about with proportions. Test the claim that the proportion of children who contract polio is less for children given the Salk vaccine than for children given a placebo. And if you want to know more information about this, one of the sidebars in your book on page 420 talk about this study in 1954. Here's another test that needs a two sample significance test. Test the claim that the subjects treated with Lipitor have a mean cholesterol level that's lower than the mean cholesterol level for subjects given a placebo. Inference about two proportions. Now we are going to deal with a two sample z-test of proportions. Notice when we do proportions, it's always a z-test. That doesn't mean much to you now because we have not done any other types of testing. But when we talk about means, we will introduce t-tests, and when we talk about variance, we will talk about the chi-squared test. Here are the important variables. They're not much different than what we did with one proportion, other than the P bar and the Q bar. So what we do for the P bar and the Q bar is we throw everybody in the same pot. So we look at the number of successes in both samples, and then we look at the number of individuals in both samples. And so in other words, what this is the average of the p hat, or we call it's the pooled sample proportion. And that becomes important when we do the z-test by hand. If you're looking on page 416 in your textbook, they give you the important equations. So here's what has to happen. We have to have two independent simple random samples, meaning that one does not influence the other. And then for each of the two samples, we need to have at least 5 successes and 5 failures. Now, I boiled these down into 2 requirements. In your book, they talk about 3. First of all is 2 simple random samples, and number 2 is that they are independent, that what you pick for the first sample has no influence on what happens to the second sample. And here is the z-score statistic. So we talk about our null hypothesis is the proportion in population 1 is equal to the proportion in population 2. Now sometimes that null hypothesis is written proportion in population 1 minus the proportion in population 2 equals 0. Those are equivalent statements. But here is what happens. We find the difference between our p-hats, our sample proportions, and we take away the assumed differences in our two population proportions. Then that standard deviation that's underneath is the square root of our pooled proportion times our 1 minus that pooled proportion over n1 plus the pooled proportion times 1 minus the pooled proportion over n2. This can get a little tedious when you're working with those fractions, but guess what? We're going to use StatCrunch to do this. So we are going to, again, we're going to concentrate on the p-values. We can do the critical values, and again, if you really want to do those, read in the book how to do it. But again, because our time is limited, we're going to focus on the p-values. And then our confidence interval, again, our estimate is the difference between the two population proportions, and we have the difference between our sample proportions plus or minus the error. And here is our error. It's our critical Z, and we find it just like we have in the previous sections, but notice that under the square root sign is just a little different. We use the sample proportions, so p hat q hat from sample 1 and p hat q hat from sample 2. Again, this isn't difficult. It just can be a little tedious, and you do need to know how to use your calculator. But again, we'll look at how to do this on StatCrunch. So do people have different spending habits depending on the type of money they have? We looked at 89 undergraduates, and they were randomly assigned to two groups, and they were given a choice of keeping their money or buying gum or mints. And then the claim that money in large denominations is less likely to be spent relative to an equivalent amount of money in smaller denominations. So we're going to use a 0.05 significance level. So what we did, group 1 we gave a dollar bill, and group 2 we gave 4 quarters. Notice that we had 12 people in our dollar bill group spent the money out of 46, and 27 people given the 4 quarters out of 43 spent the money. So here we have our p hat 1, our p hat 2, and then we have our pooled p. And let's check it. They were randomly assigned, and so we consider them independent. And then we have 12 successes and 34 failures, 27 successes, 16 failures. So in other words, we've had at least 5 successes and failures in both groups. There's our claim, and our one group was the dollar bill group, and the 2 group was the quarter group. So we think the proportion is going to be less in the dollar bill group than it is in the quarter group. So we're going to state our claim, but if it's false, here is what it would be. And I'm going to say we know that our null hypothesis is always an equal statement. So in other words, our null hypothesis states that the proportion of money to be spent in the large denomination group is the same as in the small denomination group. And sometimes when you're writing your hypotheses, it's nice to put them in sentences because it makes them more understandable, more tangible. And again, our claim is the large denomination group will spend that at a smaller rate than the small denomination group. So notice how that our claim in this case is the exact same thing as our alternative hypothesis. So we're going to use a significance level of 0.05. We're going to calculate all our stuff before we put it in the formula. Here's the formula. There's the numbers in the formula. Notice that most of the time this difference between P1 and P2 will be 0. That comes out of your null hypothesis. And we get a z-score of a negative 3.49. Let's pause here a minute, and I'm going to pull up StatCrunch. So in StatCrunch, I'm going to do stat proportion statistics to sample, but again with summary. And so I'm going to do the number of successes in group 1, and remember that was my dollar bill group, and there were 12 successes out of 46, and in my 4-quarter group they were 27 out of 43. I'm going to do a hypothesis testing. We are hypothesizing that the difference is 0, and we think that P1 is less than P2, so that means their difference is going to be negative. And we compute. And here we go. We get the same Z statistic. What I'm going to point out here is look at our p-value and think about what that means when we compare it with our alpha. So we know we got a z-score of a negative 3.49. Think about where that is on that distribution. If you have your table A2 in front of you, or if you remember, we only go up to 3.5. So and down to a negative 3.5. So this is very, very far out there in the tails. So our test statistic is way out here in the tail, and here's our p-value. We can either find it from the table or from StatCrunch, which we already did. And let's go back to our procedure list. And so since our p-value is less than alpha, we reject the null hypothesis. And I'm going to tell you, when you start doing this, I want to see this statement. Now, there's a little shortcut that we can make it a little less wordy, but there it is. And so because the p-value is less than our alpha, we reject the null hypothesis, so we can say there is sufficient evidence to support the claim that the people with money in large denominations are less likely to spend relative to people with money in smaller denominations. Now, one of the things that we need to be careful of is all these subjects were college undergraduates, so we can't generalize this to the whole population. So our sample has to represent the population we want to make inferences about. We will we could make inferences to 18 to 25-year-olds, talking about college undergraduates. And again, here is the data from StatCrunch. You can see we get the exact same p-value. We will come up with the exact same conclusion. Now we could also do a confidence interval to estimate the difference between the two proportions. So if we want to test if they're different or not, we do an inference test. If we want to estimate the difference between the two population proportions, then we are going to do confidence intervals. And because we estimate the standard deviations, the conclusions based on a confidence interval could be different than the hypothesis test. So we want a 90% confidence interval between the two population proportions. Does that agree with what we just decided? So we're going to calculate the error, and so we come up with our error. Remember our critical Z, we get that off table A2. And so the common critical value for 90% confidence interval is 1.645. And again, here we did it on StatCrunch. On StatCrunch, we're just going to click the radio button for confidence intervals, and we did put in our 90%. And here we get our lower limit and our upper limit. And we're going to write our confidence interval just like we did for single samples. So here we go, and I'm just going to use this one because it to me is more concise. Now notice 0 is not in there. So this tells us that the two sample proportions are not the same and they're negative. So that does indicate that the proportion of people who spent their money in the dollar bill group is probably less than the proportion of the people in the 4 quarters group. So again, there does appear to be sufficient evidence. And I would do this because to me this kind of is wordy. You could say there is sufficient evidence to support the claim, or this study suggests that money in large denominations is less likely to be spent relative to an equivalent amount in many smaller denominations. This basically tells us why this works, and you can read these slides. It's also in your textbook. I'm going to leave that up to you. This is in essence the proof. I'm not going to teach the proof, and you are not going to need to reproduce the proof. Remember, when we do the p-value method and the critical value method, they really are the same. We just get to our decision in a little bit different manner, but the decision will always be the same. When we want to estimate the differences, that's when we're going to use our confidence interval.